In this video, we'll talk about solubility product. Before that, let's discuss what is solubility. So if we take a certain amount of solute and we mix it in a certain amount of solvent, what we get is a mixture which is called as solution. The maximum amount of solute that can be dissolved in a certain amount of solvent, that is called as solubility. So maximum amount of solute that can be dissolved in a certain amount of solvent to prepare a saturated solution. A saturated solution is the one where we have the maximum amount of solute. So if we add any more than that solute, no more solute is going to dissolve in that solvent. Usually the commonly used unit of solubility is grams per liter, which simply means number of grams of solute dissolved in 1 liter of a solution to prepare a saturated solution. What is solubility product or solubility product constant? When we prepare, let's say, a saturated solution, so if I prepare, this is the green and the white balls, let's say this is my solute, and I'm trying to prepare a saturated solution in water here. So this solute, when this solute is mixed in water, if it is a saturated solution, usually we have some solute left behind, and there is always some particles that are dissolved, that have dissociated into ions. Usually whenever a solid is mixed in water, for example, let's say if I take AgCl, I mix it in water. Whenever a solid is mixed in water, an ionic compound, it usually dissociates into ions. So silver chloride will dissociate to give us silver ion and chloride ion. Okay, there is always some solid present, and there are always some ions that are present in the solution. And this process of dissolution of the solid usually forms an equilibrium. So the dissolved ions are in equilibrium with the undissolved solid compound, which forms a heterogeneous equilibrium. Heterogeneous because this is a solid on the left side, and these are all aqueous ions. The equilibrium constant for this equilibrium equation is called as the solubility product constant. For instance, for this reaction, AgCl dissociates to give us Ag ion and chloride ion. If I ask you what is the equilibrium constant for this equation, the equilibrium constant, as we have seen before from chemical equilibrium, is product over reactant. So that would be concentration of silver ion times concentration of chloride ion divided by AgCl, but we will not include AgCl because it is a solid, so it is not included. So this is the equilibrium constant, and because it is specific for solubility of this compound, we call it Ksp. There's nothing new, it's nothing different. This is same as Kc, only difference is because this is specific for solubility of a compound, we call it as Ksp. So it's the same what we have seen before, which is product over reactant, concentration of product over concentration of reactants. How would we write these ion product expressions, or basically the solubility product Ksp? If this is my salt, PbF2 gives me Pb and 2F. That simply means my Ksp is going to be Pb 2 plus ion to the power of 1 because the coefficient is 1 times fluoride ion to the power of 2 because the coefficient is 2. So this is same as the equilibrium constant. Only difference is we call it specifically solubility product. Example for a salt like this, it is going to be Ksp will be magnesium ion concentration times fluoride ion concentration squared. Remember, these are multiplied, not added. Salt like this, Ag2CO3 would give me 2 silver ions. We see there are 2 silver ions here, so it dissociates to give me 2 silver ion, dissociates to give me 1 carbonate. So Ksp is going to be silver ion to the power of 2 because the coefficient is 2 times carbonate. Next is calcium phosphate. Calcium phosphate has 3 calcium ions, so it dissociates to give me 3 calcium. 2 phosphate, so it has 2 phosphate. So Ksp is going to be calcium ion concentration cubed times phosphate ion concentration squared, and that is the Ksp expression. Example, write the ion product expression for these salts. Let's try, we have already tried a couple, so let's try this part B. Iron 2 hydroxide, iron 2 means Fe 2 plus, hydroxide means OH minus. How do we get the formula? We cross over the charges to get ionic compound. That means I need how many Fe? This is 1, so I need 1 Fe and I need 2 OH ions. So this is the formula of the solid. When it would dissociate, it would give me 1 Fe ion 2 plus and 2 hydroxide ions, because I have 2 OH here and 1 Fe, which means my Ksp expression for this is going to be Fe 2 plus to the power of 1 hydroxide ion squared. So that would be our Ksp expression for this particular salt. In this manner, there are multiple examples on this slide, so please practice some more examples and you can compare your answers to this. Ksp again is a fixed value. For example, most of the salts have their own Ksp value. That depends on what is the solubility of that salt. Okay. But one very important thing to remember is Ksp and solubility are two different things. Ksp has an expression. Ksp is the equilibrium constant. It's a constant term. Okay, and solubility is given by gram per liter, or it has other units, but solubility is the amount of substance that is dissolved in a saturated solution. Okay, and Ksp is the solubility product constant. So these are two different things. Ksp tells me how soluble a compound can be. Same thing with solubility. Solubility tells me how soluble a compound can be. Okay. Solubility can also have another units. One other unit of solubility is molar solubility. What is molar solubility? When we measure the amount of solute in moles. So the number of moles of solute that can be dissolved in 1 liter of solution, that is called as molar solubility. So it is going to be moles of solute in 1 liter of solution. So it's same as molarity essentially. That is why it is called as molar solubility. How can we find the molar solubility of any solid? That's what we'll look into now. For example, if we take the example of calcium hydroxide will dissociate in water. It has 1 calcium, 2 hydroxide, so it will give me 1 calcium ion and 2 OH ions. Because we are interested in molar solubility, usually what we do here is we are interested in how much solid is dissolved at the end. So I'm interested in knowing how much is the solid that is dissolved at this point. How much calcium is dissolved, how much hydroxide is dissolved. So I want to know the concentrations of these. Since it is equilibrium, the only way we can find the concentrations at equilibrium is by forming an ICE table. Meaning I need the initial, change and the equilibrium concentrations for each. So let's say my initial for calcium hydroxide, we don't care because this is a solid, so usually we do not include it in the ICE chart, or it's not part of the expression, so we don't care about it. Initial concentration of calcium and hydroxide is 0. Let's say change here, because this has a coefficient of 1, this is going to be plus x, and this has a coefficient of 2, this is going to be plus 2x. Why plus? Because both of these are products. And what is equilibrium? Equilibrium is initial plus the change. So 0 plus x gives me x, 0 plus 2x gives me 2x. So for this, I can write that Ksp for this salt is going to be calcium ion concentration times hydroxide ion concentration squared. And remember, these are all equilibrium concentrations. For calcium, it is x. So Ksp is going to be x times 2x for hydroxide, but squared, which means I can say that Ksp is equal to x times 4x square, which gives us 4x cube. This x right here is the molar solubility of the salt. X right here is molar solubility of calcium hydroxide. So from this expression, if I rearrange it, I can get x cube is going to be Ksp divided by 4, which means x is going to be cube root of Ksp divided by 4. So that is how we basically find the relationship between molar solubility and Ksp. So whenever we make the ice table for this, x is basically going to be equal to the molar solubility of this salt. Okay, whenever the question is asking you find solubility or molar solubility, we are solving for x, specifically molar. If it's asking any other unit, we have to convert that into that particular unit, but molar solubility is x, and Ksp is already, we know it is the expression, equilibrium constant expression for this reaction. Example question like this: calculate molar solubility of BaF2. The Ksp of BaF2 is given to us as this. So BaF2, molar solubility means I'm solving for x. BaF2 is the solid. Remember, always it is going to be the solid, and the equilibrium is between the solid and the ions. So this will give me barium ion and fluoride ion. How many fluoride ion there are? There are 2. Because of the subscript, I can tell there are 2 ions of fluoride, so I'm going to write 2 right here. Now, because I want x, I need to make the ice table, so this will be ICE. I do not care about this because it's a solid. Initially 0, 0, plus x, plus 2x. 0 plus x is x, 0 plus 2x is 2x, which means Ksp for this is going to be barium concentration times fluoride squared. So Ksp is given to us. Ksp is 1.84 times 10 raised to power minus 7 equals x for barium, 2x for fluoride, and it is squared, which eventually gives you 4x cube. So x cube is going to be 1.84 times 10 raised to power minus 7 divided by 4, and x is going to be, I have to get rid of this 3, so I would take all of this and I would raise it to the power of 1 by 3. That is how you write it in your calculator. If it's x cube, you raise everything to the power of 1/3, and that should give you your value of x, and that x is the molar solubility. If we plug this into the calculator, it should give us 3.58 times 10 raised to power minus 3. So remember, this is cube root. The way we plug this into the calculator is you put everything to the power of 1 by 3. Another question kind of very similar, so you guys should try this on your own and then please match up your answer. Barium nitrate, again, is the solubility is given to us. The solubility of barium nitrate is given to us in gram per liter. Question is asking what is the Ksp. So if I write the expression for this, BaNO3 whole twice, it's going to be a solid. It will dissociate to give me barium ion and 2 nitrate ions, both aqueous. The question is asking what is Ksp, and what is Ksp based on this? Ksp is barium ion concentration times nitrate ion squared, which means I need this at equilibrium, I need this at equilibrium. How can I find these at equilibrium? Again, I have to make the ice table for this. I don't need this. 0, 0, plus x, plus 2x, x, 2x. So I'm solving for the Ksp, which means Ksp is going to be x times 2x squared, which is 4x cube. So if I can solve for x, I can plug that value here and then I can solve for Ksp. Now the question is, how do I find x? What's given to us is solubility is 27.50 gram per liter. S is 27.50 grams per liter, and we know what is X. X is moles per liter. So I just have to convert these grams into moles. How do we convert grams to moles? The relationship is molar mass. Remember, this grams is given. If I want to convert it into moles, my conversion factor is going to be 1 mole is molar mass of the substance. So we have to find what is molar mass of barium nitrate, which means mass of one atom of barium. There are 2 nitrogens here, so 2 nitrogen, 1 barium plus 3 times 2, multiply the subscripts, that gives me 6 oxygen. So we'll take mass of all of these, take a sum of that, and that is going to be the molar mass for this. So if we try to find the molar mass of this, we are going to find the molar mass of each of these from the periodic table, and the molar mass comes out to 261.338 grams, which means I want to convert 27.50 gram per liter into moles. So let's work with units. I'm going to rewrite this here, 27.50 grams per liter. I want to convert grams to moles, so the conversion factor is 1 mole is 261.338 grams. So out of the two, which unit goes in the bottom? Because my starting unit is gram, I'll put grams right here, which is 261.338 grams, and 1 mole goes on top. Gram go on. My answer is in mole per liter. When you solve this, your answer comes out to 0.1052 mole per liter or molar. So this is my X. Now from here I can solve KSP. KSP is going to be 4x cubed, which means it is 0.1052 cube, which if you plug in your calculator gives you 4.657 times 10 raised to the power negative 3. So that basically is how we can solve for this equation. The question says calculate KSP, write down the expression of KSP. If you want KSP, you need equilibrium concentrations of these, which means I have to make the ice table. And once I make the ice table, I'm solving for X, and the only information that helps me solve for X is the solubility is given to me in grams per liter. X is moles per liter, so I should just convert grams per liter into moles per liter. Okay, this table is just a way for you to help and practice the questions. Okay, for example, what is the expression, KSP expression for this salt? What would be the concentration of the cation here, concentration of anion here, and what would be the relationship between KSP and S? Only difference here is that they are using molar solubility as S, whereas we used it as X. That is the only difference. We are just using a different letter for it, so it's not anything much different. What would be the expression for this? KSP, for example, would be salt Ag ion times chloride ion. Okay, so for example, if I write AgCl, gives me Ag plus, Cl minus. Ions, remember, are always aqueous. That is what makes them ions. They have to be they dissociate because they are mixing with water. So cation ion concentration is going to be plus X. This is also going to be plus X. So this is X, this is X, and the relationship between KSP for this is going to be silver ion concentration, times chloride ion concentration, which is X times X, which gives me X square. So KSP is X square. That's basically what this table wants you to do. So I would advise you practice this. Okay, for example, let's do one more and then you can try them on your own. AlOH whole thrice solid will dissociate to give me 1 aluminum. How do I know it? The subscript is 1 plus 3 OH minus, because I have 3 hydroxides. So aluminum 3 plus. So what is my KSP expression? KSP is going to be aluminum 3 plus to the power of 1 hydroxide cubed. And because of this is going to be x, this is going to be 3x. So this is x, this is 3x because of the coefficient. If I make 1 mole of aluminum, I would be making 3 times the mole of hydroxide, which essentially means KSP is going to be x times 3x cube, which would give you 3 cube. So 3 times 3, 9 times 3, 27, x 4. So here KSP is going to be 27x to the power of 4. Okay, so you can practice these expressions and the relationships, and the answers are given to you. Okay, only differences, remember we are using x, and here what has been used is s. So there's nothing different here, just a different letter. Please complete the table and compare your answers. There are some more questions that I would let you guys try and practice on your own. They're very similar to what we have done here, and these are the questions. Please try and practice them on your own, and if you have questions you can contact me. The answers are also provided to you in the slide. So pause the video, practice them, and then compare your answer to the final answer.